Assalamualaikum dan salam sejahtera semua. Okay, hai semua para guru, ibu bapa yang dihormati dan para pelajar yang cikgu kasih sekalian. Okay, selamat datang ke Pusat Tuisyen YouTuber AYU. Okay, usaha sama e-didik Malaysia dan Kelab Guru Malaysia. Okay, bermula percuma, selamanya percuma. Okay, untuk mendapatkan keberkatan kelas kita pada petang ini, mari kita sama-sama mulakan kelas dengan membaca umum kitab Al-Fatihah. Okey, apa khabar para pelajar yang cikgu kasihi semua? Okey, harap semuanya berada dalam keadaan yang baik, bersedia untuk meneruskan kelas kita pada petang ini. Okey, cikgu percaya pelajar-pelajar dah tak sabar nak mengikuti kelas kita pada kali ini. Okey, pertamanya cikgu kenalkan diri dulu. Okey, nama cikgu, Cikgu Nik Mawar Hanifah binti Nik Hassan, okey, ataupun Cikgu Mawar Kimia dari Kuantan Pahang. Okey, cikgu selaku moderator pada petang ini. Okey, so hari ini kita ada kelas tuition Kimia PAYU. Okey, pada petang ini kita bersiaran secara langsung dari channel Teacher Lau Chaiwi, atau Teacher Vivi Lau. Sesiapa yang belum subscribe Teacher Vivi Lau, silakan tekan butang subscribe sebagai tanda sokongan kepada Teacher Vivi Lau. Untuk maklumat semua, nama penuh beliau ialah Teacher Lau Chaiwi dari SMK Tinggi Klang. Tajuk yang akan beliau sampaikan ialah atomic structure. Khas untuk pelajar kimia STPM semester 1 ataupun ulangan 1 nanti. Pelajar dan para penonton lain juga dialu-alukan untuk mempelajari topik berkenaan. Kelas ini kita akan berlangsung lebih kurang 1 jam. Bersama cikgu di studio pada petang ini. Bersama kita ialah Teacher Tang. Teacher Tang mengajar kimia matrikulasi dari Kolej Matrikulasi Selangor sebagai control host. Bersama kita juga Cikgu Syahnun. Cikgu Syahnun dari Kolej Matrikulasi Pulau Pinang. Dan juga merupakan KP bagi tim Kimia AYU. Beliau sebagai pemerhati pada kali ini. Sebelum kita teruskan kelas, suka cikgu nak ingatkan semua pelajar dan penonton yang ingin menghantar komen agar menggunakan bahasa yang sopan, gambar profil yang bersesuaian untuk tontonan umum. Sila fokus pada isi pelajaran yang akan disampaikan dan hanya menggunakan ruang chat untuk mengisi inilah untuk menjawab soalan ataupun kalau ada soalan yang nak diajukan. Akhir siaran nanti kita ada share link ECJ. Dan hanya ada 30 minit saja untuk mengisi maklumat. Pastikan menggunakan email EDD. Cikgu percaya semua yang hadir pada petang ini ialah pelajar-pelajar yang cemerlang. Mari kita tunjukkan disiplin yang baik. Cikgu harap semua dapat memberikan tumpuan semasa kelas ini bersiaran. Sebelum cikgu serahkan kepada cikgu Teacher Vivi Lau, cikgu nak umumkan kod yang pertama untuk pada petang ini ialah A3. Huruf A3, A3. Tanpa membuang masa, cikgu serahkan kelas kita kepada Teacher Vivi Lau. Dipersilakan.
Okay, thank you, Cikgu Mawar, for the introduction. Good afternoon, teacher and students. Today, I'm going to share with you about the topic atomic structure. Before that, I would like to thank the teachers on the stage here. We have Cikgu Shannon as a pemerhati. He's our ketua panitia, ketua PAYU for subject chemistry. Then with us, we also have teacher Tang as a control host today. And just now the moderator, Cikgu Mawar Kimia. So let me introduce introduce myself first. So my name is Lau Chaiwi. I'm currently teaching in Pusat Tingkatan 6 SMK Tinggi Klang. I have 19 years of teaching experience. Then this is my YouTube channel, Vivi Lau. Here is a PU teammate. So first we have Maths Department, we have Teacher Im as a Ketua Panitia. Then we have Teacher Eileen, Teacher Zainaria, and the other teachers. Then this is the Biology PAYU team, which is led by Cikgu Faiza. Then this is Physics teams, which is led by Madam Rosmaya. And we have Accounts and Economy, team which is led by Madam Fiji. Okay, so this is our chemistry team. So we have teacher Tang, Cikgu Shannon, Cikgu Mawa, and teacher Kong. Okay, so before I start the lesson, I like to share with you this gas point app. Okay, so I like you to answer this question. Where are you from? Okay, so you go to the gaspoint.app and enter the gas code 49273. Okay, so later the other question also I use this one. Gaspoint.app. So I give you a few minutes to try out. If you have problem, you can type in the chat box. So now I would like to see your answer. So you go to gaspoint.app and enter this gas code and type your answer. Okay, so we have first answer Selangor. Okay. So I give you around 1 minute. Okay. So the question is, where are you from? Okay, so only we have one response, never mind. We have Penang now. Okay. I wait for one more students to enter the, okay, Negeri Sembilan. Okay. So we have North, Central, and Negeri Sembilan consider Central also. Okay. Of Malaysia participant for this. Okay, so I go to the next slide. Okay, so I would like to know how do you feel today. You also can try this one. So you continue just now, you roll on this one, on this slide. Okay, you can, if you are happy, you can roll happy face. If you are tired, you can roll a tired face. I think nobody is angry now. So this one also I give you 1 minute. Okay, so we have one happy face here. Okay, happy face. Okay. Very good. All are happy today. Okay. One more student. Cikgu Shano happy. Namata also happy today. Okay, so I close the submission. Okay, so we look at. Okay, so today I'm going to talk about electronic energy levels of atomic hydrogens. So the learning outcome is to explain the formation of the emission line spectrum of atomic hydrogen in the Lyman and series using Bohr's atomic model. Okay, so we have Bohr's model of hydrogen atom. Okay, so Niels Bohr is a Danish scientist. So he proposed a model of hydrogen atom to explain the formation of light emission spectrum. Okay, so the model of hydrogen atom. So atom has electron, and the nucleus we know have proton and neutron here. Okay, so nucleus we have proton and neutron. Okay, then the Bohr's model is focused on the electron. Explain about the electron, how the electron move in the, okay, so you see here. So his model explain how the electron move in the orbit around the nucleus with specific energy. Okay, so explain about the line spectra. Okay, so the electron has certain amount of energy. Okay, electron at certain distance from the nucleus has certain amount of energy. So the energy of an electron is quantized. Quantized means has specific amount of energy. Okay, so the movement of electron or transition of electron from higher to lower energy level will emit a specific amount of energy in the form of photon. So means the light. Okay, so it will emit the light. Okay, so let's look at the difference between continuous spectrum and light emission spectrum. So this is a continuous spectrum. Okay, so like a rainbow. Then we have light emission spectrum and light absorption spectrum. Okay, so most of the time we discuss about the light emission spectrum. Okay, so the table show the difference between the continuous spectrum and the light emission spectrum. So for continuous spectrum, light is emitted over a broad range of wavelengths or frequency. Okay, so it's a range. So it's continuous. However, for light emission spectrum, the specific frequency of wavelength appear as lines. Okay, so it has line. So it's not continuous. There are spaces between the lines. Okay, continuous spectrum show emission of wide range of energies. Okay, light emissions spectrum has only certain amount of energy are emitted. Okay, so in between empty space. Okay, so continuous spectrum has continuous, smooth, and no refinite lines between the colors. So all continuous, all the colors merged together. Okay, for the light emission spectrum, there are discrete lines or refinite lines, not continuous. Okay, so each line is separated by blank areas. Okay, example of continuous spectrum is light from the light bulbs or rainbows. Then for the light emission spectrum is from the atom. For example, here we specific to the hydrogen atom. Okay, so let's look at the Bohr model of hydrogen atoms. So an electron can only have certain discrete energy levels. Okay, so you look at, so the discrete energy level represented by the number n, principal quantum number, this is called. So it's a specific orbit around the nucleus and not in between the orbits. So you look at this one. Okay, so the electron only can move from one step to another step, but cannot move. The electron cannot stay between the step because it's empty space. Okay, so like just now here, so electron only move in the orbit. Okay, cannot move between the orbits. Okay, so when sufficient energy is supplied to the atom, electrons jump up to a higher energy level. Okay, so when the electron absorb the energy, it will jump up to a higher energy level excited. So you can see here, ground state electrons possess the lowest energy level. So n equal to 1 is the ground state. Okay, so in the ground state, electron are stable. Okay, when the electron absorb energy, it will go to the higher state, which is the excited state. Then it's unstable. Okay, hence the electron that is excited will emit energy, as in the form of electromagnetic radiations when it falls back to the lower energy level. Okay, so it will falls back and emit energy in the form of electromagnetic radiation as a light. Okay, so the relationship between the energy of a quantum of radiation and its frequency is this formula. Okay. Okay, the PowerPoint freeze for a while. Okay, wait for a second. Oh, sorry, I present the slide again.
Okay, para pelajar dah harap bersabar ya. Kita ada technical problem for a while. Everything okay, teacher Vivi Lau?
Still opening. Okay.
Okay. Okay, sementara kita menantikan teacher Vivi Lau, kita persilakan untuk iklan seketika.
Tuisyen online percuma. Tuisyen online percuma. Layari www.academyyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma mestilah Akademi YouTuber.
Okey, cikgu nak umumkan kod kita yang ketiga. Okey, tadi cikgu dah umumkan 2 kod. Okey, yang ketiga, kod yang ketiga ialah nombor 1. Okay, number 1. Okey, teacher Vivi Lau dah bersedia ke?
Oh, sorry, the PowerPoint has problem. I trying to open it.
Okey, dia harap para pelajar bersabar ya sebab kita pun tak nak ada technical problem macam ni. Okey, kadang-kala dia akan berlaku. Okey, so kita menantikan teacher Vivi Lau baiki mana yang patut.
Teacher Vivi Lau macam mana?
Oh,
Still
okay,
stuck?
sir.
Still stuck?
Okay.
Maybe
okay, I share screen. Sorry. Okay, just now we are here.
Okey, dia harap anak-anak pelajar bersabar ya.
Okay, so we look at the formula. Can see?
Okey.
Can see?
Okey, boleh teacher Vivi.
Okay.
You can proceed.
So the formula is
Okay.
delta E equal to H nu. So delta E is energy difference between the energy levels. Okay, for the transition. H is the Planck's constant. Okay, the value is 6.63 times 10 to the power of negative 34 joule-second, or depends on the equation. Okay, so sometimes can be 6.6256 times 10 to the power negative 34. Okay, so if you want to convert to mole per mole, you have to multiply by Avogadro constant, 6.02 times 10 to the power 23. Okay, so you will get the Planck constant value 39.91 times 10 to the power negative 11 joule-second per mole. Okay, so if you have information about the wavelength, okay, because okay, sorry, because nu is frequency, or you can write HF. Okay, so nu is C over wavelength. Okay, so if you have information on wavelength, you can use this formula. Okay, so C is the speed of light, 3.0 times 10 to the power 8 meter per second. Then wavelength lambda is a wavelength. You normally it's nanometer. Okay, nanometer. Okay, so we look at this one. So each line in the light emission spectrum correspond to the electrons flow from one specific energy level to another specific energy level. So you can see here. So if the electron falls from 3 to 1, okay, so you can have one line on the light emission spectrum. Okay, so if the electron falls from 2 to 1, then you have another line, okay, from the appear as at the light emission spectrum. Okay, so for the calculation, Okay, so when the electron absorb energy, it will promote to higher energy level. Okay, so it will emit the same amount of energy when it falls back to the ground state. Okay, so the calculation is delta E for the transition is equal to the energy at 3 minus energy at the 1. Okay, n equal to 1. So you get the H nu. So each photon released contains a quantum of energy with certain frequency. Nu is a frequency. The frequency corresponds to the specific line in the spectrum. Okay, nu. Okay, so as you have to pay attention that when the frequency increases, means when the energy level gets closer, when the energy level increases, like n equal to 1 until n equal to 6. So the line will get closer also. Okay, so the line also get closer. Okay, energy like closer, when the energy level increase, the line in the spectrum also become closer together when the frequency increase. So when you roll, you have to make sure the lines become, the spacing between the line become close together. Okay, this one you have to pay attention. So here the energy level also increasing. So here is higher energy level. Here is a ground state. So higher. Let's say this one is 4. Okay. Okay. This one is light emission spectrum. Okay. So means this one is a light transition. Okay, so means this one is n equal to 1 ground state. Okay, when the electron move from n equal to 2 to 1, then this one 3 to 1, 4 to 1, and this one 5 to 1, and the fourth line. So the energy level get increases. Okay, so we have question because the first question. Okay, so I show the answer already. Okay, never mind. So here I show again. Which of the following explains why the emission spectrum of hydrogen is a line spectrum? Okay, so you try to answer this one. Which of the following explain why the emission spectrum of hydrogen is a line spectrum? So you can use just now the this one to type your answer. You go to classpoint.app, enter the same class code just now. Okay, then type your answer for the question. Which of the following explains why the emission spectrum of hydrogen is a line spectrum? Is it the electron in the hydrogen atom can only reside in certain energy levels, or because the spacing between the energy levels get closer with increasing frequency, or the electron radiates energy when it drops to a lower energy level? Okay, or D, the single electron in the hydrogen atom moves around the nucleus in fixed orbit. So here we have 3 student answer already. So let's see. Okay, so we have 2 students answer A, 1 student answer C. So got 1 more student. Okay, so I give you until 3 minutes. I think nobody answered. Yeah. Okay, so I close submission. Okay, so so we have two students answer A. Okay, very good. So the answer is A. The electron can only reside in certain fixed energy levels. Okay, so that's why we have line spectrum. Okay, so we see this one. So this is an apparatus to produce the light emission spectrum. This is called spectroscope. Okay, so in the spectroscope we have a gas discharge tube. Okay, so it has high electrical potential energy. So it will provide heat energy to the atoms. Okay, so the atom will absorb energy and become excited. Okay, so the electrons will emit energy again. Okay, when the electron falls back to the ground state, then light is produced. Okay, then the light will go through the slits and focus to the prism. Okay, then prism separate the light. Okay, so these are the explanation. Okay, so the hydrogen molecules is go through the discharge tube. Okay, with high electrical discharge. Okay, so we'll break up the hydrogen molecule into atoms. Okay, so the single electron normally at the lowest energy level. Okay, so because of the high energy in the discharge tube, the electron will absorb energy to be excited to the higher energy level. Okay, so it's unstable, so it will fall back to the ground state. Okay, so you emit energy in the form of radiation. So this radiation gives the light spectrum. Okay, so each line is has a particular frequency or wavelength. So that is how the light emission spectrum is formed. Okay, now we look at the emission series, series of hydrogen spectrum. So we have here show the Lyman series, Balmer series, and the Bastian series. Okay, so Lyman series is in the UV light, okay, ultraviolet regions, and the Balmer series at the visible light region, and Bastian series is at the infrared region. Okay, so you can see here the Lyman series, the ground state is n equal to 1. Then Balmer series, the ground state is n equal to 2. Okay, so means the transition is to the n equal to 2 from higher energy level. Then Bastian series is to the n equal to 3. Okay, so beside this 3, we also have also have another 2 series. Okay, so we can see later. Okay, Becker and Piffen series. So we have this diagram shows how the movement of electrons. Okay, so you have to know how to roll this one. Okay, so always show the energy axis. Okay, y-axis is the energy axis. Okay, so you have to roll the energy level. When energy level get higher, the energy level get closer. So you have to roll the line getting closer. Okay, so until infinity. Okay, so when you roll the electron transition, okay, so you have to see the question mentioned what series. So here is Balmer series. So that's how so just how is the electron move from higher to 2, right? Then ground state is n equal to 2. Okay, so n equal to 2 is a ground state. So we start from 3 to 2 first. So 3 to 2, 1 line, from 1 line. Okay, then 4 to 2, 1 more line. Okay, then the 5 to 2, 1 more line. So you can see the lines spectrum also getting closer when the energy level increases. Okay, so here is a frequency. Okay, this thing broke it, you cannot see. Okay, So I write again here. So this is a frequency increases. Okay. So means energy level increases here. Because E equal to HF. Energy increase, frequency increase. Okay, then we continue just now 6 to 2. Okay. So if from the infinity to the ground state, we have all the lines merged together. Okay. All the lines merged together. So this one is limit of convergence. Or you write new infinity. Okay. Limit of convergence. So you can use this one to calculate the ionization energy. Okay. So ionization energy, later you will learn. Okay. So it's you take the Planck constant multiplied by the frequency or limit of convergence. Okay. So you can straight away get the ionization energy. Means the electron can overcome the attraction of nucleus and be removed. Okay. Okay. So we have to pay attention for the rowing. Okay. So just now the n is the principal quantum number. Okay. And the colors of the visible region is caused by transition of electron from higher to n equal to 2. So for Balmer, it's n equal to 2. You have to memorize the ground state. Okay. Then when the energy level gets closer, the line also gets closer. Okay. Okay. So the table here showed all the series. So that's how got bracket and P-fun. Okay. So Lyman Balmer is more important for STBM. Okay. So Lyman, the series, the ground state. So this is ground state. Means the electron will go back to n equal to 1 for Lyman. For Balmer, n equal to 2. For Bastians, go back to 3. Okay, bracket is 4. P-fun is 5. Okay, then the range also you have to memorize a region or range. Okay, so Lyman's situated at the UV light. Okay, you also can write UV. Okay, then Balmer is visible light. Okay, Bastian, bracket, and P-fun are infrared. Okay, so the frequency decreases. Lyman has a highest frequency. So UV light has the highest energy. Okay. Okay, so we look at question 2. So an electron of hydrogen atom is excited to an energy level n equal to 4 and falls to a lower energy level n equal to 2. Calculate the frequency and wavelength of this transition if the energy emitted is 4.088 times 10 to the power of negative 19. Okay. So just now the formula, if you forgot, I give you one. It's this one. Okay. Then you also, because you are asking to find wavelength also. So if you select wavelength, it's this one. Okay, so you can try to calculate now. So it's transition between n equal to 4 and n equal to 2.
Okay, student can try to answer the question 2. Okay, by using the formula given by Teacher Lau.
So very easy. Okay. Just substitute the answer. So for this one, you just type in the chat box. This one I didn't give you any the interactive question.
Okay, student can answer at the YouTube chat.
You answer in the YouTube chat because this one I didn't give you the interactive question. Okay, any answer from the students?
So far, not yet. No one answer yet.
So we have this one is the energy. Okay, so maybe you forgot the Planck constant value. Okay, so Planck constant just now is 6 point something. Uh, 6.63, right for you, 6.63 times 10 to the negative 34. Okay. Or you can use 6.6256.
Okay, the H value is a represent a Planck constant that will be given in your question. Your exam question will be given the Planck constant. So no need to memorize actually. So teacher Lau, I just wrote the Planck constant. H equal to 6.63 times 10 power of negative 34. So you can try to calculate it.
Just substitute, okay? Maybe C also I give you 3.0 times 10 to the power 8, okay? So this one is joule second. This one is 10 power 8. This one is meter second per second. Okay, meter per second. So you substitute here for the any answer from the student?
Okay, so far no answer yet.
No answer. Okay.
Okay, maybe teacher Lau just show the answer.
Okay, because now already 4:15. Okay, so I just show the answer. Okay, so I show you the answer. So just substitute only. Okay, so nu of frequency equal to the energy divided by Planck constant. So you'll get 6.17 times 10 to the power of 14. So you must write the unit per second because Planck constant is joule second. Okay, then the wavelength. Okay, so wavelength, because you know this one already. Okay, so wavelength equal to C over F. Okay, if you want to do from this formula also can. Okay, so if you calculate from your wavelength, your frequency answer here also can. Okay, so you will get 4.862 times 10 to the power negative 7 meter. Okay, or depending on the question didn't ask, you just write per meter, stop here enough. Okay, if the question asks for nanometer, then you convert to nanometer by dividing by dividing by 10 to the power of 9, okay? Okay, times 10 to the power of 9. Times 10 to the power of 9, you will get 486 nanometer, okay? So this one, question 2, okay? Now we look at third question. Okay, so this one you can use the classpoint.app to answer, okay? ABCD, you can use this one. Okay, this one very easy. Which of the following diagrams best represent the line spectrum for hydrogen atom in the visible light region or visible light range? Okay, you try to answer here.
Student can try to answer the question 3. You can just put A, B, C or D on the chat box.
Okay, so if you don't want to use this one, you can type in the chat box. So got one student answer B already. So I minimize the response.
Okay, Chan Jun Kit answer A.
Okay. So just now the answer here is B. Okay. Got two student answer B. Okay, so very good. So the answer is B. Okay, because just now already mentioned when the frequency increase, energy increase, the energy level increase, the line must getting closer to each other. Okay, so remember this one. Okay, now we look at show you the answer. Okay, I show you the answer. Okay, so I straight away discuss the answer. Okay, so which of this electron transition in the hydrogen atom has the longest wavelength? Okay, so this one you have to look at this formula. Okay, so wavelength is opposite, okay, from the frequency. So when the frequency smaller, wavelength will be higher. Okay, so means the energy is equal to wavelength energy is proportional to frequency, right? Energy increase, frequency increase. Okay, so means the energy must small here. So you have to choose a small difference in energy. Small difference in energy. Okay, small difference in energy. So you have to see from here. Okay, because small difference here we have 1, 2, right? 1, 2, 3, 4, 5. Okay, so you see the energy difference getting smaller between n equal to 5 and n equal to 4. Smaller energy difference. Okay, so the answer is A. Okay, so here the energy difference big. Okay, so the small energy difference, smaller frequency, because we want the frequency small, we want the longer wavelength. Okay, so longest wavelength. So you must choose the answer 5 to 4. Okay, so here we have another question. Calculate the number of lines formed for the electron transition between n2 equal to 5 and n1 equal to 1. Okay, so you can write your answer in the chat box or you can type here. Okay, the short answer. Okay, so you have to count. Okay, how many number of lines can form between electron transition between n equal to 5. This one back to the ground state 1. Okay, so you can roll out or you will just count only also can. So if you roll out, okay, Okay, you roll out one by one. Count, okay. 2 to 1, 1 line. Okay. 3 to 1, 1 line. Okay. 4 to 1, 1 line. 5 to 1, 1 line. Okay. So you can get the answer. So what is your answer?
Student can answer question 5. Okay, how many lines?
So from 5 to 1. Okay. So any answer?
Chan Jun Kit answer 4.
Answer 4. Okay. No more answer.
Not
Okay,
yet.
Yamata also 4. Okay.
Z Zin Chai also answer 4.
Okay, very good. So the answer is 4. Okay, so you can see I wrote 4 here. So n equal to 2 to 1 lines. Okay, so you also can use a formula. Okay, so the formula is n2 minus n1. So n2 is a final energy, and 1 is a ground state. Okay, so 5 minus 1, so you get 4. Okay, this is a formula method. Another method is you just roll out the lines. Okay, or you don't roll out also can, you just count. Okay, count only 2 to 1, 3 to 1. Okay, so we have 4 lines. Okay, so we have another question. Calculate the number of lines formed for electron transition between n1 equal to 2 and n2 equal to 5. Okay, so now this one is just now is from higher energy to lower energy level. Now this one is from lower energy level to higher. Okay, so the n1 is 2, n2 is 5. Okay, so we try to do.
Chan Jun Kit answer 3. Teacher Lau.
Okay, 3. Any more answer?
Okay, only Chan Jun Kit answer for this time.
Okay, so because this one didn't specify. Okay, so because this one the line is from n1, the transition is n1 2 to the n2 5 higher. So let's see the solution. You have to write out all the possible series. Okay, so you have to find out all the possible series. So we have n2 is a final, then n1 is a beginning. So 5 minus 2, you get 3. Okay, so line more of lines we can have until 6. Okay, you have to see the drawing, only you can understand. Okay, so you have all the possible series, because the question didn't mention what. Okay, so you can have Balmer series 1, because here don't have 1. Don't have 1, so means you don't need to roll for the Lyman. You just roll Balmer and the Parsons and this one bracket. So you will get 1 line, 2 line, 3 line, 4 line, 5 line, and 6. So about 6. The answer is 6, not 3. Okay. Because the question didn't specify what series. Okay. Any question from the students?
Okay, so far they have no question, but Chan Jun Kit said that was so tricky.
Oh yeah, this one, I think this question is
Yeah, the keyword is the most
purposely want
important.
so that you know, because I didn't mention the best, so you have to you will see this type of question, you have to show all the possible one. Okay. Okay. So next question. One of the lines in the spectrum of hydrogen atom has. So this is another type of question. You also learn wave number. Okay. So wave number is 1 over f 1 over wavelength. Okay. So what is the frequency of this line? Okay, so wave number is this one. Okay, so frequency is equal to c over wavelength. So you straight away substitute the wave number. Okay, you will get the frequency. Okay, so this is one type of the question. Okay, now we look at the subjective question. Okay, so the diagram below shows the first 3 series of lines obtained when an electrical discharge is applied on a sample of hydrogen gas. So here you can see 3 series, A, B, and C. Okay, so the question asks, name the series of lines represented by B. Okay, so you can do this one first. Name the series of lines represented by B. So the way to answer this is you look at the frequency. Okay. So you see where is the highest frequency.
Chen Jun-Kit answer Balmer series.
Here got 3. B. Okay, Balmer series. Any more answer?
Okay, no more. Okay, Zinchai also answer Balmer series.
Okay, very good. So this one, second one is a Balmer series. Okay. Because the highest frequency here, so means this one is the Lyman series. Okay, followed by Balmer series. Okay. Second, state the part of the electromagnetic spectrum in which series B is formed. Okay. So this is part region. Okay, part is region or range. So where's Balmer series region?
Okay, we have 1 minute here, Teacher Lau.
Okay,
1 minute before 4:30.
Okay, so I'll give you the answer straight. Okay, so I'll give you the answer straight. Okay, so Balmer series, you know, is in the visible light region. Okay, so visible light region. Okay, so to the question. Okay, question asks you to sketch the label energy level diagram. Okay, for the transition in electron of frequency 3.29. Balmer series. So you must show like this. Okay. 6 to 1. Okay, that's how 3.29 is here. Go back to the question so that you can see. Okay, 3.29 is here. So here is highest frequency here. This one Lyman series. This one just now you say Balmer. Okay, so 3.29 is the highest frequency. So you can see here is 1, 2, 3, 4, 5. So means this one is 6 to 1. Okay, n equal to 6 to n equal to 1. So you have to roll from n equal to 6 to n equal to 1. Okay, so must label the energy. Okay, Then show the transition from 6 to 1. If you show infinity also can. Okay, then calculate the energy. Okay, emitted. So 3.29. So you just use a Planck equation. Planck constant multiplied by the frequency 3.29. So you get the energy. Okay. So that's all for today's sharing. Okay, thank you, students.
Okay, for Chan Junkit and Zinchai, okay, congratulations because support in this session. Okay, so both of them got the correct answer lah. Okay, so terima kasih diucapkan kepada teacher Vivi Lau, okay, di atas perkongsian ilmu yang bermanfaat. Dia memang ada susah sikit untuk this topic, tapi you can master this topic if you know the content, the concept. Okay, tahniah diucapkan kepada semua yang setia mengikuti kelas kita pada petang ini dari awal sehingga saat ini. Okay, sebelum kita tamatkan sesi siaran langsung, okay, mohon tutup ruangan chat, klik butang subscribe yang masih merah dan aktifkan ikon loceng supaya para pelajar tidak terlepas sesi kelas yang seterusnya. Okay, sekiranya anda suka apa yang dipelajari pada hari ini, klik like, share kepada kawan-kawan di media sosial anda, FB, Insta, okay, untuk sebarkan ilmu, okay, dan beroleh kebaikan melalui perkongsian tersebut. Okay, and then link sijil kita boleh dapatkan pada bahagian chat. Okay, sila ambil perhatian. Okay, link akan tamat dalam tempoh setengah jam. Okay, selepas live ini iaitu pukul 5. Pastikan anda guna email e-didik sahaja. Okay, sekali lagi cikgu ucapkan ribuan terima kasih kepada teacher Vivi Lau dan juga cikgu-cikgu yang bertugas pada petang ini. Okay, jangan lupa untuk dapatkan jadual tuition online terkini di portal www.academyyoutuber.com serta dapatkan info terkini. Okay, bantu cikgu untuk sebarkan kelas tuition percuma kepada rakan-rakan, guru-guru seluruh Malaysia. Semoga kita mendapat manfaat daripada kelas-kelas yang dijalankan. Okey, sebelum cikgu end the session, cikgu nak umumkan kod, 2 kod yang terakhir iaitu 99. Okey, 99. Okey, kod yang terakhir. Okey, dan di dekat ni juga ada dah diletakkan pada ruangan komen juga ada dah diletakkan kod presenter. Okey, pelajar-pelajar boleh ambil di situ. Okay, jangan lupa hashtag bermula percuma selamanya percuma. Okay, terima kasih kepada semua. Segala yang baik datangnya daripada Allah. Jika terdapat sebarang kekurangan, kelemahan adalah daripada kami. Kelas tuition online percuma berakhir sudah. Di lain siaran berjumpa lagi. Assalamualaikum. Bye-bye.
Okay.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Dan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.